All right, good morning, everybody. August 23rd. I hopefully you watched the 11.3 dot product videos. I am aware that in 11.3, the C, section C, where we did vector decomposition, there is a much shorter way that doesn't involve the dot product. And I think it's worth showing in class because it would be the way I would do it on the test unless I was compelled to use the dot product method. So the very example I had in the video was we had vector B and we wanted to decompose it into two vectors, a vector B and a vector orthogonal to B. And we were given both vectors, V and B. We know that V equals B plus this is the orthogonal vector. So that orthogonal vector equals V minus B if I just subtract B over. Now, we didn't do that. I didn't really do that until the end of the video. Why don't we just do that now? What is V minus B? 3, 4 minus 4, 2. I hate, fuck off, Google. I do not know why my phone is always answering shit. I'm not asking it. It's trying to tell me how to do math. We'll just slap it. 3 minus 4 is -1 and 4 minus 2 is 2. So we can see that's right here. And if I draw the vector, I can see that if my vectors look, if my drawing is good and everything's evenly spaced, that should look like approximately a right angle. If it doesn't, if you sketch it and your sketch is okay, and it doesn't look like a right angle, you probably made a mistake. To me, it looks a little bit wider than 90 degrees right now, but that's just because I think this shit gets a little wider over here. So it's good enough. I think that's what it is. And then rather than going through all that to find K1 and K, breaking these down into unit vectors and stuff like that, we can simply just divide each of these by the magnitude of the vectors. Let's call this vector C rather than B orthogonal. So that'll be C. B would be, if we find the magnitude of B, 4 squared plus 2 squared is 20, square root of 20, which is 2 root 5. So B, if we do the unit vector for B, let's call it E1, B divided by the magnitude of B is going to be, we had 4, 2 over 2 root 5. We got 2 over root 5, 1 over root 5. And if I do the same thing over here, magnitude of C is square root of -1 squared plus 2 squared is square root of 5. So E2 would be -1 over root 5 and 2 over root 5. And we know these are the scalar multipliers to make those. So I could say V equals 4, 2 plus -1, 2. And then I can say that's 2 root 5. If I really needed the unit vectors, if you really need the unit vectors, you would go the next step and do this part. But you usually don't. Square root of 5 from C. But the question was, let's get this. So we did all that without having the cosine and sine and all that, doing all the pictures and stuff like that. Simply subtracting the vector over and dividing by the magnitudes would give you the unit vectors. But this is the direct answer right away was that. That was, good morning, Adam. That was where 11.3 video C probably got confusing. It's the harder way. It does show the dot product and one of its uses. And then other scenarios, if we weren't trying to find C like this and didn't have B, there's problems where it comes up. Are there any questions on that? Or is there any questions about 11.3 in general? We had the dot product. We saw directional angles. There's projections in there.
Wow, they're speechless. Yes, you got a question?
You can achieve the same thing but minus the projection beyond the V.
He's asking, can you achieve the same thing with the V minus projection of V, V on the V?
Should. Let's take a look at it. So let me.
Okay.
And so we know V equals B plus B orthogonal. And let's see, picture. One second. And if we're going to do projections, V is should be the projection onto B plus the projection onto the orthogonal B. Look at that equation again real quick. Yeah, that's what I said. All right. Projection onto B of V plus the projection onto, I called it C, so let's call it C here. V. So this would be, as the question was, can we just use V minus the projection? Let's take a look at what happens. Let's see if we get the same thing. We should. So projection of V onto B. We have the dot product over the magnitude of B squared. That gives us a scalar value, and then we multiply it by B to get give it a direction. This avoids the use of E. Let's see, V dotted with B. 12 plus 8 is 20, so we got 20 on top. Magnitude of B. We did magnitude of B. Magnitude of B was square root of 20. Look at that. Square root of 20 squared times B, and we just end up with B, which makes sense. So now you're right back to V minus B. So using the projection method still gets the same thing. That was the question, right? Any more? Maybe if you guys work on some problems, you'll develop some more questions. I will give you a little taste of where 11.4 is heading. Real quick, notice that we had U dot V equals magnitude of U, magnitude of V, cosine theta. That was 11.3. In 11.4, we're doing another form of vector multiplication, cross multiplying. Guess what goes here? What always goes with cosine? What's cosine's best friend?
I'm only hearing whispers. Sine.
Sine. This was not a trick question. It's like
Pretty
Bert and
good,
Ernie.
right?
They go together. So you'll see that they're similar. So that's what you're doing in 11.4. Go ahead and work on problems on, let's check with Zoom. Is there any questions on the Zoom users that I can answer in class? Otherwise, we can work on
Nope.
problems.
Just saying good morning.
Yeah. Well, it takes time to type. Let's see what it is.
Yeah.
All good.
Oh, you have a question?
Final answer. Yeah, what about this? Yeah, that is question. 12.3. Also called and questions. So that's the question. I can get better. So I do it. Obviously.
Okay. Thank you, Christopher.
No, we're using, and, that's the club. That's 66. And so what are we? Yeah, it's the.
That's the end of it. How do I know it's off? But I the angle's greater than 90.
Hey, Mr. Jones, do you happen
Yes,
to
sir.
have taught the textbook Thomas 4th edition? 14th, right? It's
Yes.
14th edition. It's not one assigned to this class, apparently.
I don't know if I have one here, but we can go look and see what loaded in the good old Discord channel.
Yeah, I believe it was in the Discord too.
That's all the answer. I don't know how to do the answers, how they get them.
Is there a question from it that we need?
Yeah, he had a question. It was a word problem, so it's kind of hard to explain.
So chapter, chapter 12.3 is also a dot product. I'm using this textbook in the Calc3 2.
Okay.
So I start early before they close it. Yes. Question 16.
I thought you did 34, but I don't know what to do with that. Yeah, probably.
Right there.
Okay, let me read it. Okay, let me go back up and see if they mention anything about grade. It looks like that's the angle of incline. Because that's what grade is on the highway. Like if you're driving on the freeway, grade measures your steepness.
Look it up. It should be like the tangent.
How does that make it powered? I don't even know. Here, I'll grab it. Those are points. I thought the numbers.
They're technically vectors. So that's just showing, that's an angle.
I want to make sure my because the picture is crappy. It's got north pointing downwards and east pointing to the right. I want to see if there's anything else on. I don't want to look at the solution. Wow, they're all like that. Okay. Back to the book. That's not the book.
How does that work with this one number? I don't understand it. Is there any, I guess you're supposed to just take it at face value? I don't know. Well, to figure out if this is what it's worth. Agree on 11.3. Determine whether it's
Okay, I'm going to go back to the picture and I'm going to try to redraw it.
Oh. Oh, I know.
Because the wording on this is pretty poor. The picture's even worse.
I was just looking at my notes tonight. So make sure I have it. Keep that great.
Is there any way I can just share my notes with him?
Still an awesome thing. Quite awesome.
So let me share, bring this up. So if I draw something based on the normal system here, 20% grade off of north, the way it looks like what it's doing to me is 20% that way, 20.
Yeah.
I think.
There's a proof behind it.
So you just guys don't have you just guys take it. Yeah, just take it
It's oh, I have a little bit. So you would be your unit vectors and you feed off these one and it is equal to 0 where if I percent theta is equal to 1, percent theta is equal to 0. That's from that. If you graph it that way, if it's graphing, sure, it does show that it's equal zeros, right? Negative.
Huh.
And then like a little bit for
Yeah, I mean, it's
I hate looking at the like someone's solutions, but like where are they going? I need to see what that picture actually means before I solve it.
Well,
Just so
I
disgusting.
draw it on my
Just so that it was this-
stuff.
Yeah.
Well, that's all I have. Yeah, no, I understand.
You know what?
Like here, they're using a cross product. That's not the way we want to go.
Like, well, if they go instead of going to the negative angle that way, do that. But then you still go all the way around.
It's not about it.
Yeah, it's not a thing, it's not about.
Yeah. The negative.
How is it, how does it appeal for optics?
Well, when I use this doing this question, it was on the that Pearson system.
I don't think that.
Okay.
If you can go to the this score, the Friday night lab on the help, I
Yeah.
I just put in there around May.
Around May
help.
and
Help.
hope. Okay.
What does it say that?
They're using random number, so it's gonna be a little bit different.
The magnitude, so you find it, you can use it through the, regular dot.
And that's what I did.
The magnitude of those in the dot, like,
And two different ways, and they come up with like
There you go.
different answer. It should be the same, right?
They should be the same if you did it two different ways. It should still be the same answer. Let's see.
Zero, that is orthogonal.
Go back. Where are we? Oh, here we go. So my question, I would be wondering where you got the 100 and the, like, where are you getting these figures with the hundreds? Because that's not in the problem.
I know, I just giving them
Okay,
because the 25% is the ratio, right?
So because.
So
because the equals
if that's 25%, I can just give them 25, then the lay down is 100, right?
yeah.
You want to break, so
I
it's
guess
the
I
how
think
long.
maybe that length doesn't matter.
You predict that this will assign that this will.
I think I did that one
Instead.
before.
Is that you?
Well, I wasn't. I didn't.
And it does have to do things. Just
You're
very
Jason?
each other.
No.
I think I did it like everything referenced to
Does
B.
that.
So
If this is negative, then this will also be negative.
Yeah, this question is
Because- so
drawing me
A was
up
negative
since
equals- if it's a
May.
negative number, like, that means
That's what I thought
And
too.
I don't
Adam,
know
let's-
what I don't really know what I did wrong, Doc, but
one over here. Right. That's CJ.
So if I were to go about this with a dot product approach, we're looking with at a BA dotted with BC, right? So cosine theta would be BA dotted with BC
For mathematical terms.
over their magnitudes.
So remember the, the definition of dot product, right? Dot product.
yeah, you see.
U dot B is equal to the magnitude of U multiplied by the magnitude of B and cosine of theta.
Yeah.
If you input the.
So,
magnitude
Uh,
of the dot product,
I like the use of the 100 because that can, I could treat that triangle you have there. Let me overlap this on it.
This is another way.
Let's figure out what BA is. Let's treat B as the center. Let's say B is the center
Yeah, so.
Yeah.
it's just-
origin.
it happens to be a way to find it.
So BA is going like the Y component, X is 0. Not, no, it's going in the X direction. Damn phone.
Okay.
Let's say X is going in the 100, Y is
Mm.
going 0, Z is going down 25.
25.
And then BC, that's my BA. And BC, I would line up, it's not going any in the X, it's only going east, which would be Y. It's going 100 in the Y, and it's going up 10. And I would use these two in this to figure out cosine theta.
That one goes down.
So
and
let's-
there's the
Yeah.
next-
We can do that together real quick. Let's see, what's the magnitude of BA?
back to 20.
We've got
Magnitude
100
of
squared
BA.
plus 25 squared.
Square plus 25 square and times.
I'm gonna leave it as the square root of 10,000. So magnitude BA is 10,625 square root.
Plus
Magnitude of BC is should be 10,100.
1.7.
So what's BA dot BC?
EA dot BC.
We got
next
0,
is
0, we got
flat.
negative 250, right?
Mhm. Yeah, got that right.
So
What
what is, I'm gonna do 10,625 times 10,100. I'm gonna take the square root. And I'm gonna divide negative 250 by that answer.
Hmm.
So when I do that, I'm getting cosine theta equals negative 0.02448. If I do cosine inverse, I'm getting one, which can't be right. Oh, this is in radians.
Yeah, make sure that is.
So let me multiply by 180 over pi.
Oh, I see why.
91.4 degrees.
I was gonna say, isn't that like higher than-
Okay, I see what I got wrong.
I got the 1.59 something.
Yeah, that's the correct
So
answer.
is that what you did? I wasn't
Yeah,
looking, I was just
I-
looking at your picture. Let's see what your work did. It looks like you might have done the same thing.
Yeah, I didn't use the dot product for the first place.
God. You just went straight all the way to the law of cosine. I'm impressed. You went straight to the law of cosines formula and took the long way home. I like it.
I mean, because the first place I using dot product, I just learned it from the book and it wasn't go well in getting the wrong answer. And now I know, finally I know why it's wrong.
Okay. Let's see.
Yeah.
Yeah, your U and V, you scale. I'm looking right here. Your U and V, you've scaled down by, you made the length 10 rather than 100.
Right. Because I don't know how to do it. And Pearson, the system, they show your example. And I just follow their example.
I
And,
think
the
the
V is
magnitude of-
wrong.
is this right for the magnitude of U?
Yeah, I think so, but the V setup wrong. The V should be 3.5, not 1. Because when you go back there, go back to the picture, and it's like based on A point is reached like 25 plus 10. So I set it wrong though.
I think using AC here hurts, makes it a little harder.
Mm-hmm.
Oh, okay, so, and that's anything you want to do.
But it looks like you used it correctly because I got that value right there.
Yeah, that's geometric way. You can't get wrong from that.
So I did get that.
Yeah, I heard you talked about that one.
These
Yeah, that one.
values, this U looks correct, this V looks correct. I'm
No,
not
V
sure
is wrong.
about this U.
V should be 3.5K
No way.
Why though?
because I take U is from the bottom. That's
Oh, you're
um,
you.
is 0, so that reads 3.5, not 10 anymore. 3.5, not 1 anymore.
Oh, yeah. You're okay. Your 0 is down here.
By itself.
Right.
Okay, yeah. That's what's off.
Okay. I got it. Thank you. Though.
Yeah, it helps to label what your origin is.
Right.
Or look at like the.
Well, you're at the point where it's equal because I feel that.
Look at you with the tricky problem. I like it.
On the U dot.
This is technically correct. This is the,
This is the definition of that.
that's a definition. Yeah.
What is this? How do you get that?
That's just, I don't know, that was just right here with the vector, that's the magnitude.
Oh, so that's a different thing. You didn't-
That's not, I didn't get that anywhere. I made that based on like my understanding of the magnitude. That's the basic, the length of it.
Oh, I see. Oh, I see.
And now you see the dagger. But are those the values that are in vector itself?
Yes.
Okay, that's what I was trying to confirm.
That's the, but you have to.
Oh, backwards, okay, yeah.
And that's the-
Oh, yeah, because the X and one.
Yeah,
That was a third one, then it'd be like, what is it out here?
yeah, that would be, yeah. It would
No,
be-
this would be green, and then.
Yeah.
maybe
That should be
It
X.
should be X, so it's 1, and then 2, 2. That was just for conceptual.
Yeah.
And the same would be for the. It's only a-
Unless it's.
Yeah, no, I'm those. I wanted to confirm. Sure. Fine. Probably just writing down like correct. Yeah, I see. That's how I feel. That's why I like that. I'm using the book answers. If I don't have like the answer somewhere, I'll point and say it's like thinking about like, is it right?
If anyone on Zoom has questions, go ahead and ask. That's what we're here for.
I'm glad you're here though. That's helpful. It's cool.
And if you weren't here at the start of class, I recorded the beginning. You might want to come back and watch it later on. There's a much easier way to do the finding the orthogonal projections, not projections, the orthogonal vector than what I did in the video.
That makes sense.
You think I'm gonna pass out the exams?
You have to have a lot of stuff.
Well, that's not it. That's probably not it. There's
Okay.
probably some,
You have like,
there's probably some people who.
yeah, you know,
It's probably something along the same lines of why I can't have the key to this room. Yeah, like take home test.
you have to take in class.
Oh no.
To take home that you have to and other classes, go back to the class.
The same day.
Same thing.
Did you hear that? They want an extra test. They want a take-home test that you have to collect the same day.
What the fuck? I mean, I'm not going to your houses to pick up the test. Yeah, I'll give you a take-home test, but you can't leave the room and it's due an hour later.
Exactly. So you can get home fast.
Oh man.
Rackheads.
Well, actually, you better.
I'm hearing a lot. I want a hard test.
They've been saying it ever since they walked in. It's crazy,
Right?
right?
You know what they say, ask and thou shalt receive.
And being there, it's like, what's the letter that's ended?
Oh, what's the letter that's the most?
W is literally in W.
I feel
No, it's W is not W, it's W.
a little hair.
Double V.
You don't get this confused, you get a set of a double U, depending like different from double V.
I like how there's like W, so it's like you're doing U twice, but you call it W. There's a double. Yeah, that's why we don't do that because that's we use what is the Greek symbol to like stand there. Everyone around the world and stuff.
Yeah.
So when someone else, like someone across the world sees the word, they're like, oh, that makes sense. Instead of like, what are all these symbols you came up with? You got like a smiley face?
I mean, I haven't stopped America before.
Yeah.
Smiley face plus the. Oh, yeah.
Absolute value of smiley face. No, absolute.
Oh my gosh, could you imagine if like
Absolute,
suddenly like teenagers read like rule of what math symbols were looking like?
absolute value of sad face and happy face.
Oh no, I gotta, makes me wonder which one they're gonna delegate to Among Us. Red Among Us.
Absolute value of
It would definitely be an imaginary number.
angles for me.
Even though no, Red Among Us would be the imaginary number.
Representing the sign of it outside. Get this on the cosine. With this, which gets these values. So if I need an example right here. So B, or B, whatever those arrow probably. Say vector V. So you write it as like the arrow. I honestly prefer the arrow with like one of the notches on. Versus like where it's like back, it's easier to write. Then it looks kind of weird. Weird is that like, I don't know. It could be like, if you just leave squiggly, you use accent up there.
With how you do vectors.
I like that one, but it's better on paper. For writing. So
I really don't like it when I really couldn't stand like when it's.
I use this for on when I'm writing on here, but I think I'll use the. It's on the book. I like that for
The text like just bolds that are vectors, which
nice.
thankfully they're able to separate their bolded letters from their actual different letters. The bold vectors because they're bolded letters.
See. Oh, I never see good.
So do you able to answer your question?
Yeah, I know we're setable for we already.
And I'm gonna solve for theta. I'm solving for theta, and then I'm gonna do the dot product. So I can.
I'd probably get more if you were some of the stuff that they have out now though. I don't know if they have them, but I just know they're horrible.
You're You're what's the
I wish I was. I wish I was.
oh man, you don't want to more.
I can see my coffee cup on the projector. Let's see.
There's the camera towards.
Let's stop blurring background.
Oh my gosh. Tipsy.
Wow. Is that Skylanders?
Touch
Oh,
my coffee, I will slap you so hard. Not even
Even
Google will find you.
Oh my gosh.
I thought that said something else. Because it was blocked. It was blocked by the bubble.
Tears of my students. It's the
yes.
lettering has worn off because it's gotten so much use from people crying during tests.
Many tests were ruined during those days.
Oh, here's another fun one. A student bought that for me.
Oh my gosh. I remember seeing something that said, "Don't bother me until I've had my coffee," and even then, don't bother me.
So, and then another student bought me this cup. It's kind of hard to read. It's since I like to cuss, it's all the different contractions that we use with cussing. Like there means they fucking are. There shows fucking possession. All the different weird contractions. It's got cussing in every single one.
Oh, you're welcome. Okay. It's really this kind of problem. Actually, too, so I feel it carry around the house. My house, we have like a shelf in my house. To go up there. I'm sure it's probably come grab up to the shelf. I don't know why. Yeah, I can't get into that. Or was it? Yeah, no, I have no idea where to go. This isn't working out very well. I just realized once I plug in these, I still don't have this. And I'm trying to get this. Unless I
Oh,
get
you're trying to
that.
find a way to make find theta.
Yeah, but it's still this, so I can't really do that. I don't know. I just want to make sense of it.
Sometimes it's just fun to play around with the equations, see what you can do with it.
These are the vectors. I don't know why. This was like my eyes.
Yes.
Someone's gonna write down everything. Like the cosine. That's also basically. Vector B. Beta. What? Beta.
What would be tomorrow?
Beta.
Tomorrow? 11:24.
What's tomorrow's section?
11.4.
11.4 then.
Let's see.
Oh.
Let me check that. Let me check
I
the
think I
schedule.
got a peek at it. I think I got a peek at it too. That's gonna be fun. They're gonna finally learn some actual. They're gonna learn some matrices. Matrices.
Let's see. Where is my schedule? Syllabus. Check the syllabus. Oh, it looks like we're still doing 11.3 tomorrow. So
Oh, really?
if you've got more if you've got more questions on 11.3, bring them. Try to see what you've got figured out, and we'll be working on 11.3 more tomorrow. If you start on 11.4 and are working on that, well, we can do both.
That makes sense.
Oh, pass on to 1 hour.
The test. How long is the test?
What do you mean? Duration wise?
Oh yeah. Well, he's coming. Because you're coming early for the test, aren't you? Like half hour to an hour early.
I'm gonna try to be here at 7 a.m. And the test should hopefully only take you an hour. But I figured if I do 7 a.m., I can give you guys, we'll be here till 9. I'll be there till 9. If you feel like taking longer, want to have more time in your work, yeah.
For students, doesn't like, hopefully, that word.
Oh, so the 6th is a Tuesday. Oh, fun. Oh,
Yeah,
that's
Mondays,
fun.
the Monday before it is a holiday. And there will be a review out next week. I'm going to be working on it this week. Review out that week. And even though it's a holiday weekend, I'll still be doing Starbucks. Hell, we can do Starbucks on Monday if you guys aren't doing shit for, what is it, Labor Day, Veteran Day? I don't know what day it is.
I think it's Labor Day. It's
Labor
Labor
Day.
Day.
Veteran Day
If
is-
you guys aren't doing shit, I can do shit on Monday too.
28 hours later.
But that's the following weekend.
Yeah, that's gonna be a little bit.
Is child labor still illegal if you pay them?
And I don't want to answer that question. Nor do I know how to answer that question. Do I look like a lawyer to you?
No, I guess I gotta contact.
That's the problem. If you don't pay them, that's not labor.
It's not like, that's called slavery.
Yeah.
What?
Oh wait,
No.
that practically
It's just-
that practically
I guess
exists. It's
They're
called
just
school.
generously helping.
They're generously helping.
Oh man. Basically, what you're making it sound like is school is a way of student slavery where you pay them for the luxury. Man.
You guys should just go visit China and see what their students do. You know, they're behind. You know, they probably never get out of the classroom during the day. They're behind bars, and you go home with like lots of homework. You're not gonna sleep before 11. For kids.
Probably. And thinking
So-
about the propaganda they put out. Anyways, go ahead.
Adam, for the Zoom users, the schedule is, I can show it to you guys real quick before class ends.
My goal today is to finish this problem. that I put in. Actually, no, I'm gonna do another problem because I finished that one.
Where's it? There
Well,
it is.
don't worry. You still have another 12 hours to go.
So for Wednesday, August 24th, we're still working on 11.3 for tomorrow. If you want to get started on 11.4, I can definitely talk about 11.4 tomorrow too. This is, I wanted to move a little bit slower when we got into the dot product and cross product, because this stuff is kind of important for later on. We use it a lot. So if you want to, if you're ready to watch the videos, watch them. If you're still working on 11.3, work on 11.3. That's for Adam. He was asking on Zoom.
Do you have any last thing before they start really trickling out?
No, get out. Go do your homework. I'll see you guys tomorrow, okay?
Where's my-
Yep.
Peace.
Oh, there it is. One